Hello. I think.
Okay. Hello, everyone. Thank you for joining this seminar series organized by the Empathic Computing Laboratory. I'm your host, Aladdin, and our guest speaker for today is Misha Sra, who is currently an associate professor at UC Santa Barbara, where she leads. Assistant professor at UC Santa Barbara. Thank you. Where she leads the Human AI Integration Lab. She has done a lot of research in the HCI, AI, and XR domain, and her work received many awards and media coverage that attracted the attention of industry research. The title of the talk is Augmenting Humankind, and the talk will be roughly an hour, followed by brief questions and answers. Please join me to welcome Professor Sra. Thank you for joining us.
All right, great. Thank you for the introduction, and thank you again for inviting me. It's really nice to be able to talk to folks on the other side of the world. I really admire all the work coming out of your lab, so it's really wonderful being here. All right, so as Aladdin mentioned, I am going to be talking a little bit about what I think, how we could augment humankind, particularly using AI and XR technologies. All right, so if we sort of take a step back in time and look at our being humanity's quest for augmentation, we can go pretty far back in time, right? And this is just stuff that has documented evidence, but I'm pretty sure humans were talking about this stuff way before then. Starting with the epics of Gilgamesh, let's say around 2100 to 1200 BC, we see the notion, the quest for immortality begins, or documentary quest for immortality begins. Then we look at mythology and how Apollo wanted to shoot with 100% accuracy, the bows and arrows, the arrows. Then stories, of course, talk a lot about augmentation. Comics take it a step beyond, and we look at Black Panther and how we're talking about super high speed and all sorts of other abilities that go beyond what humans can normally do. And then, of course, you look at the fourth figure here on the screen is altered carbon, where just this idea of immortality is taken to a whole nother level, where you can just switch out your consciousness and pick up any kind of body, kind of a sleeve to wear, right? And so following in that line of different ways that we've looked at augmenting humanity, the question is, how can AI, being sort of the next technology, support that notion? Right? How can we use it, and what kinds of tools can we build to augment our abilities with AI? And the idea of course, using tools to solve problems and augment our abilities is really old. It can go as far back as, let's say, looking at the Stone Age, 3.3 million years ago, when we were building stone tools that allowed us to do the things that we couldn't do until then, right? So this, we can consider tool making as a fundamental way of augmenting our abilities. Tools didn't just help us survive. Tools helped us solve problems. Tools helped us even, according to some theories, helped evolution and made our brains bigger. Then we can look at how tools, once we build them, they allow us to communicate knowledge within a community. The notion of how tools get built, that ability is shared across a community and disseminated within that community. And at some point, that skill and knowledge gets embedded in culture, and over time becomes tradition and gets preserved in the community, which then leads to this idea of humans being more encouraged to come up with newer and better tools and solving harder and harder problems. Now, using tools can also help us to consider the same problem from a different perspective. So it can help us identify the limitations of the tool itself, and which then again allows us to build different types of tools. And once we get to a point where, we've sort of met all of our needs, looking at Maslow's hierarchy of needs, we've met our physiological needs, our safety needs, and we get to the top of the pyramid, self-actualization. We use the same tools that we might be using for building shelter, for example, a hammer at the top, to express our creative needs, to, for example, be using the same hammer and chisel to carve out the statue of David, right? So the same tools allow us to do many different things. And lastly, using a tool is one way for us to learn about how to improve the material that the tool is made of. For example, we look at iron that has remained crucial throughout history. Iron powered the Industrial Revolution, and eventually it led to steel, which is an alloy of iron and carbon. And steel was much stronger than iron. And so, by learning to work with iron, we learned to improve it and turn it into steel. And steel is a material of choice for buildings, even now. Now, what's interesting about all of these tools and our history is that we have entire historical periods that are named after not the tools of that period, but the materials that fundamentally changed the type of tools that humans could build. So we went through Stone Age, Bronze Age, Iron Age, etc. And then now we can say that we're in an AI age. We're at the far end of the spectrum. And the reason I call it an AI age is that I think of AI as a material. I don't think of it as just a single tool, a single purpose tool. I think of it as a collection of algorithms, models, techniques that can be combined and adapted in many different ways to solve a wide variety of problems, create a lot of different applications and new types of systems. So one way to think about it would be to think of it as Play-Doh, right? Which can be shaped and transformed into many different types of objects, something as simple as a blob. So let's say using just something out of the box, to something a little bit more complicated, like AI can be used to create a wide range of tools and applications, from simple chatbots to very complicated systems for image recognitions, autonomous driving, speech synthesis, et cetera, et cetera. And now that, we have this idea of AI being this moldable tool that can help us solve different problems and fit into our different existing systems, the other interesting thing to notice is that all humanities materials until now, look at the dominant ones like stone and iron and bronze, they've all been passive. They're all transformable, but essentially passive. And now for the first time, we're dealing with an active material. And by active, I mean, when you use an AI system, it has its own outputs, right? Probabilistic outputs. It can make errors, and it doesn't necessarily always do what we want it to do. So this sort of opens up a different set of possibilities to build different types of tools and bring up new kinds of challenges, of course, right? And the bigger question is, what types of tools are we actually going to build? And what types of real world problems will they solve? In my research, I am very interested in using this active material to build tools for augmenting our physical skills, our motor abilities. So in other words, I'm interested in bringing AI out from the 2D world of computer screens into our 3D world. Right, so of all the physical things we do, there are 4 specific aspects of physical abilities that I'm particularly interested in. And, one is learning new skills, whether it's performing surgery or, improving sports technique or even learning a new sport. We can learn new physical skills, and an AI agent can help by providing real-time instruction, guidance, feedback, what have you. The other area I'm interested in is our ability to recover physical skills, right? So if you have a disease or you get injured, then you generally have to go through rehab therapy to recover the skills which you already had, whether it's walking, you hurt your ankle, or fractured an arm in a ski accident, etc. And so here also, I believe AI agents or AI in general can play a role in helping you recover the skills that you've lost. The third area is I'm interested in augmenting skills that perhaps you never had, abilities. For example, you have never been able to play video games, and we did a project related to this because there is no way for you to use your hands, and there are no controllers that allow you to play a game without your hands, just as an example. So how can we build tools with AI that allow you to do things that you couldn't do before? Or in the case of the second image below with Parkinson's, how can we build tools that allow you to do the things you could do once upon a time, and then you got Parkinson's and you're unable to do those things anymore, from simple everyday things to something more complicated. And lastly, I'm interested in understanding or building upon your existing abilities. Like you already know how to do something. How can we build upon that and speed up your learning of something new that's sort of in a related domain? Again, with an AI agent giving you instruction and real-time feedback to make things faster. And sort of if we expand this whole idea and look sort of down the road, far future, right? We can think about if you watch the movie The Matrix, where right before getting into a helicopter, Trinity downloads the ability to fly that helicopter into a brain. And that's sort of a physical motor skill. So we can imagine maybe down the road, this could be a possibility where our ability to learn physical skills is super speeded up. So right now, I think that AI can speed up considerably, but down the road, when we download it straight into our brains, then it could be super fast. And all of this has tremendous potential for societal impact. You look at 1 billion people, and this is sort of to scale, 1 million, 100 million, and a billion people live with disabilities around the world. And that's not to say just physical disabilities, all of them, but there's that many folks who could use help. And then there's more than half the people over 60 years of age have a disability. This is in the US. And we can expect in another 13 years, by 2035, the number of older adults in the US is projected to outnumber the number of kids for the first time in US history. And globally, we know, right, the world is graying. And so, again, we have potential for a large amount of impact using AI to help learn and recover and augment our physical abilities. There's about 100 million people each year in the US that get musculoskeletal injuries that requires rehab therapy, right? So we already have potential there. And then there are 1 million people in the US living with Parkinson's. It's about, I think, 100,000 get diagnosed each year, right? And then there's countless billions worldwide who may want to learn something new. Right, so I think by bringing AI out from our screen space, which is where it mostly resides right now, into the real world to help augment our abilities in the physical world is super meaningful and sort of a very exciting area for me. All right, so today, having said all that, I'm going to talk about, depending on time, like 2 or 3 specific projects that we worked on. One is to do with learning and time travel. And then we'll look at experiential artifacts, right, in AR. And so they are related to what my current lab's direction and vision is, but not all of them. But these are all sort of different kinds of things we're working on. And of course, overall, in general, all of this falls into the bigger space of human well-being. I'm looking at well-being more from a physical perspective than a cognitive perspective, but of course they're both related. All right, so the first work I want to talk about is using AI-generated characters for learning, right? And you may have seen a lot of these online already by now where people create these characters, but a lot of times, unfortunately, been used for malicious purposes, right? The whole idea of deepfakes. And we wanted to explore how they could actually help do something positive. Right, so
today, we will learn about quantum mechanics. It is the description of the behavior of matter and light in all its details and, in particular, of the happenings on an atomic.
Right, so I want to sort of use this as an example of a virtual instructor, and I'm going to talk about these 4 things related to the project, from questions to prior work to study design and outcomes. So starting with questions, right? And we were just having a conversation about COVID and how that changed some things. It was during COVID that we started wondering about how can we help students feel motivated to learn, when in the beginning, early days, a lot of the folks sort of were sitting, alone, maybe in their rooms, whether it was in their dorms or at home, and having to take classes online, which was something totally different from what they were used to doing. And then we wanted to also look at what if we generate teachers or instructors that are modeled after people we like or admire? Would that actually increase motivation to learn? Right. So as I showed an example,
Today,
we got
we will learn about
Einstein and
Today, we will learn about
quantum.
right. So the output you're seeing right now, these are just example virtual characters we generated using a pipeline that we built that was published as a separate paper. That was in Nature Machine Intelligence a couple of years ago. But what I'm going to talk about is an application of this for learning. All right, so our research question for this particular project was that how do AI-generated instructors impact learning performance? Right, we certainly want to see if it helps improve things or not. The second research question was that how do these AI-generated instructors impact students' emotions and impact their motivation to learn? Kind of where the whole project and conversation got started. And the third thing we were curious about was how does the degree to which students like or admire people, what kind of impact does it have on the instructor's perceived credibility, their likeness, and their ability to facilitate learning? So essentially, how are students perceiving their virtual instructors? So there's a lot of research, right? Prior work that precedes our work. And we sort of frame our work at lying at the intersection of using personal role models for learning, pedagogical agents, and AI-generated characters. And I'm going to sort of skip the details here because they're all in the paper. Just wanted to highlight that it's where our work is situated. Right. And so using the pipeline that we had built earlier for another work and advancements that, of course, happened in machine learning, we were able to put together an entire system to generate lecture videos featuring a particular target instructor. Right? So that's part of our generated pipeline. This is the output. And again, technical details, if you're interested, we can talk more about it, but they are in the paper. Essentially, we just take in audio or text and an image of the potential final output, and we can have a talking head video of whichever person we want, whatever voice we want to put them in, and all sorts of things. And the question is that how do we study the impact of liking or admiring a generated instructor? And in this case, we wanted to pick someone who is somewhat controversial, right? People might have extreme thoughts on whether they like or dislike Elon Musk. And so in our experimental condition, we generated Elon Musk, and then our control kind of looked like Elon Musk, but not a known recognizable figure. Right? And we decided to do only one character instead of having people pick one out of 10 or 15 characters we had generated, sort of to keep the number of variables we have in our study to a manageable level.
Hello, I am a virtual agent generated to help provide information. Today, I'd like to tell you about a type of vaccine known as live attenuated vaccine.
Right. And so both these characters, experiment condition and control condition, they taught a lesson content from the WHO on the live attenuated vaccine. So exactly the same thing they both taught in an online lesson. And we had about 130 participants in our study. It was a between subject study, and initially people had a quiz that they completed after the study, and then we also had a survey. We asked them questions on a Likert scale to rate many things. And so our two main variables were the liking and admiring, and they're kind of related, but not exactly the same thing. And so those two independent variables, and then we had different dependent variables, your learning performance. Let me see, right? Learning performance, motivation, and emotional impact. And so independent variable 1, we asked how much do you like this person? We had an experiment group and a control group. And similarly for IB2, we had how much do you admire, an experiment group and a control group. And so the like scale was on a 3-point scale, the admire scale was on a 5-point scale. Right, just to sort of quickly go over some of the results, right? We did not see any significant difference in the quiz scores for liking. But for admiring, we sort of see a weird bump in the middle, so if you moderately admire, it does improve your learning performance. So it's hard to say that that's a clear result or if it's some noise we're seeing, right? But this is sort of what we saw. The learning performance wasn't much changed. When we look at emotions, the question was, the instructor made me feel, and I know there's a lot of text on the slide, so it may be hard to read, but in general, if you look at the trends, for positive things, the instructor made me feel happy, the instructor made me feel content, we see a positive trend, both for liking in the top row and for admiring in the bottom row, relative to the gray bar, which is for the control group. And then for negative emotions, the instructor made me feel frustrated, or the instructor made me feel bored, we see a downward trend, which is sort of what we want to see, that if you like, then they don't induce negative emotions in you. And then the next question, we have multiple questions related to motivation, right? And one of them was, I was motivated to pay attention. And so the more you liked the character, the more motivated you were. And this trend was not as pronounced for admiration. We did not have significant difference, which is also a little bit interesting, right? That liking is significant and admiration isn't. And so some of it might be some interpretation of people putting themselves into either pool, what they think about liking versus how they interpret liking versus admiring. Looking at someone wanting more lessons from this instructor, so it's positive for both groups. And then wanting to learn more advanced materials from this instructor is also positive for both groups. So still continuing on motivation, putting in a lot of effort to understand the information, we didn't really see any significant difference between people who liked the instructor and the people who admired the instructor. And for the third research question, we're looking at whether the virtual instructor was able to facilitate your learning, right? And most everything here we see is positive. Did the virtual instructor appear credible? Did the virtual instructor appear human-like? And then lastly, did the virtual instructor appear engaging? And for both the liking and admiring groups, the trend was positive. Right. So just to sort of summarize, all in all, for short-term learning performance benefits, we didn't really see any. For research question 2 related to motivation and emotions, we saw positive trends. And then for research question 3, the instructors were also perceived as more engaging and human-like. Right? And so the one thing, so these are all great, right? We're sort of seeing some benefit here. The concern here is, the ethical side of it. We are generating virtual instructors. And because they are teaching things that they have not maybe talked about, right? So let's say we have Einstein talking about, I don't know, football or something. It is not something Einstein ever talked about, perhaps, and we're having them talk about something. So the question from an ethical perspective is, right, what are the boundaries of this? What is okay to have a virtual character say, even if it's for general good? We're using it for a positive task. And who's to decide what is the virtual characters and what can they say? And is this different from people or humans who have lived before or are currently alive, like Einstein, or is it different for fictional characters like Iron Man or somebody else that you want to use to teach, right? And so misportrayal and disinformation are certainly risks because these characters can be made to say anything. We are creating them. We also worry about replacement, right? Are students going to want to only ever learn from characters they like or admire? in an extreme case. And so how does all of this fit into the whole scenario of, we don't want to replace anybody. Obviously we can't, and we don't want to, but we want to supplement or maybe even provide help in places where there are no instructors at all. And then, so that's sort of another big ethical question. And then lastly is, how do we seek consent for using the likeness of Einstein? Maybe Einstein has an estate or somebody, family members, but all of those things need to be considered before actually trying to do something like this at a large scale or deploying it. Right, so there's raises many questions. Of course, there's not that many answers to the whole ethics thing yet. At least there are no specific guidelines other than what you personally believe that you're doing the right thing. And then there's future work. We want to integrate more complicated expressions and emotions. We want to make the whole thing interactive, and we also want to expand the study to see if doing this a little bit longer term actually has any kind of learning effect versus a one-time lecture, and also use more complex material. All right, so sort of jumping from virtual instructors into time travel, right? If you had a time machine, who would you want to talk to in the past? Family members or friends or great-great-grandparents you never got to see, or some other historical characters. Right, so broadly speaking, most human, or every human culture, I should say, worldwide has developed some kind of practices and rituals that are associated with remembering people from the past, right? Whether you do it for mourning, whether it's cultural preservation, whether it's learning about historical events, we have different ways of looking to the past to help, perhaps, for different reasons of how it can guide the present. And in this paper, we present this, the concept of living memories, which we think of as interactive digital mementos that are created from, original source materials such as journals and letters and other communication data that these individuals may have left behind. And so, like an interactive photograph, living memories are things that you can talk to. You can ask them questions, and the goal is that through this conversational system, we're accessing the knowledge, the attitude, the past experiences of this individual more accessible. And so they respond to you as they may have potentially responded to you had you been able to ask them a question in real time when they were alive. Right, so similar to the previous project, I'm just going to talk about these 4 areas for this particular project. All right, so I want to make it very clear that our work isn't about bringing a person back from the dead. We're not bringing anybody back to life. We're not cloning people. We're basically thinking of virtual or living memory as sort of the next iteration of, we already have mementos of people who are gone, whether if it's family members, then we have photos and videos and objects that they may have left behind. And we think of this sort of as an interactive photo. And the idea is more that given the amount of and the type of data we have, original source data from an individual, that these are snapshots of people at specific moments in their time, not the entire person, right? Because that's impossible, right? It's too much. And that's not what we want to do. We want to just sort of create a version of them that we can talk to at some point in their life. And so these, we can imagine, can take the form of a chatbot. It could be embodied. We can think of it as having a humanoid body in a VR, AR system. We can think of it as some other object, physically sitting on your kitchen counter that you're talking to, or just an interactive photograph that you could have on your phone. Right, so we created three people from the past. There's Leonardo da Vinci, and then there's Captain Robert Scott, and then there's the poet Murasaki Shikibu. Right, and so here's a very busy slide But again, all the details are in the paper. Mostly we want to say that the top half of the slide here, the portrait and the AI generated character pipeline and speech synthesis, so those are the same pipeline as I just showed for the previous project, right? We're generating a talking character. And then the bottom part is different for this specific work. And what we have here is sort of a two-stage process. We have a primary source input. So this is, let's say, Leonardo's journal. And then we have secondary source, which is some reliable, let's say, a Wikipedia article about Leonardo, or maybe a biography written about Leonardo or things like that. And so the first step of the process is knowledge extraction, right? So we're actually looking at real source and extracting knowledge. And then the next step is text generation. And so knowledge extraction essentially gets the paragraphs of text out from the primary source, which is then fed into a GPT-3 model to convert it into a conversation. And so to prevent GPT-3 from using any external sources of information, we convert all the instances of the person's name to me, I, personal self-referencing pronouns. And in order to keep the model also keep track of and remember the conversation, we also inject sort of the last 10 questions and answers back into the query for subsequent GPT-3 calls. So the knowledge extraction stage from a pipeline is what we use to compute a semantic similarity between the generated answer and the extracted paragraph, using the same sentence transformer as we use for extraction, right? So it is a semantic BERT. And if the computed similarity is below a certain threshold, which empirically we determined to be 0.3, and we're looking at cosine similarity, we output a scripted answer saying the living memory is unable to answer that question, right? So essentially what we're doing is you ask a question, it gives you a response, and to make sure that the response is true to the original source, we look at a similarity, we calculate a similarity of the response, match it to the original source. And we only display answers that are semantically similar because we don't want to fabricate information, right? Leonardo may not have said it, but models, and we know, LLMs and things like that can hallucinate and actually create new information that was never real. All right, so here's sort of an example, right? The Leonardo da Vinci, if you ask it a question that says, how should figures be depicted in a painting? The ground truth is information from the journal. And where it says it's related to the question that the limbs should be adapted to the body with grace, let's say. And the GPT-3 response is, as you see here, in my opinion, figure in a painting should be represented as it's seen by the eye. Which we can see the difference between these two, right? And in our version where we actually check for semantic similarity and then generate the response, our response says the figure in a painting should be depicted in a way that is graceful, which is closer to the ground truth than GPT's answer. Right? And the same thing, if we have a question, it relates to something that Leonardo could not have a response on, right? Ground truth is essentially, I'm not sure. Leonardo doesn't know anything about the United Nations. GPT-3, of course, translates this literally to what it interprets as United Nations, which is incorrect, but our version provides the correct answer. Right, so, let's look at some of the studies we did. And since these systems are sort of still in their infancy, we also came up with some kind of metrics that help us evaluate the output from our model. And so, right, we generated 600 question answer pairs, and then we evaluated our system with looking at, I'm just going to pop up all the results. Right, 4 different metrics. One is content preservation in our responses. One is style preservation. Third one is understandability, and the last one is grammar. And so for each of these, we're comparing 3 different models, right? The first is just GPT-3. The second one is the sentence, the semantic BERT. And the third one is our version where we do a semantic similarity check. And in all these cases, we can see that our model is performing fairly well in the dark orange compared to the others. So after doing sort of this technical evaluation, and again, there's a lot more details in the paper. I'm sort of going through it fairly quickly here. Right, I'm going to skip that slide and I'm going to get to the user study. And in this study, we looked at how living memory can increase your curiosity, the effectiveness of learning about a historical character, and even your motivation about learning about a character. And so the comparison here was you just read about Leonardo da Vinci, and it gives you some information, right? The second scenario was that you just interact with Leonardo da Vinci's living memory or as a chatbot representation, and you ask it a question or more questions and it answers. And then the third scenario was that you read about Leonardo da Vinci and then you interact with the living memory. And we found that that turned out to be the most beneficial. And our belief is that that's likely because once you read about Da Vinci, you have a lot more context and you're able to ask the memory different types of questions than if you don't know anything about Leonardo and you go in and try to ask questions. Right? And so this sort of goes back to what I was talking about in the previous case also, that motivation was sort of a driver for learning in that project. And sorry about that. Motivation in this case also we see is greatly enhanced. And this was a study we did with 90 people, an online study. Again, just like the last word, anytime we have AI involved, we have to talk about ethics, right? We're again generating a virtual character. So how far can we steer from the truth, or should we at all steer from the truth? Or what do we do about things like if we wanted to generate a character based on information from before science knew that the earth is not flat, right? Technically, we're true to the original content if we're generating something from the 11th century or something like that. But it's not scientifically true anymore. Which of those two scenarios should we accommodate or work with? So how do we get consent from for Leonardo da Vinci, who is to say it is okay to use Leonardo da Vinci as a chatbot? Again, user privacy, authenticity of the content is important to think about. We also want to think about overuse and dependence, right? We don't want any kind of new types of addictions emerging from this type of chatbots. And especially if you're thinking about creating chatbots of your own family members, if you're able to talk to your own great-grandpa or great-grandma, you've never met them before, and let's assume there is enough data to create them fairly reasonably well to be able to do a conversation. You don't want to do any kind of overuse, or you want to use that, again, post-mortem existence. You want to have continuity of someone you knew who's no longer here, but do you want to continue talking to them, like not letting go? It's a hard question, right? Different people will answer that differently. And then we also don't want to start using characters that people like or admire or well-known to start promoting harm, which I believe there was either a bot or an account on Twitter, which looked like one of the Disney movie characters that was promoting self-harm. So lots of questions related to ethics anytime we're building something like this. And while for research we're exploring how it can help for actual deployment, a lot more things need to be answered to make these safe to use. Okay, so now changing gears a little bit, right? Talking actually about XR and the vision, of course, of XR, we know that is living in a world where the real and virtual elements sort of seamlessly and contextually augment our experiences of ourselves and of the world we inhabit. And so, we work in this area that this integration actually is super exciting and it promises lots of new opportunities for the future of XR. But one thing we found during our experiences is this risk of experiential distortions. So feelings of dissociation, especially related to VR. And that's sort of what I'm going to talk about in a few minutes. Right. And the image I generated using Midjourney. And I took many iterations to come up with something that sort of looked reasonable to me. All right, so I'm going to talk about the context, what survey we did, and what I mean by experiential artifacts, and then how we're proposing situated VR as a potential solution to it, and then what kind of feature things we can do. Right, so we in this work, we're envisioning a hybrid future where the digital and the real are interacting seamlessly, right, in a continuum. Both are reacting to each other. There's constant exchange of information going back and forth. And that allows the users to transition between the two quite seamlessly. And so that sort of is the vision, right, of a hybrid future. And we think that inhabiting any kind of hybrid reality, if we want to do it permanently, it requires us to feel situated in both. And if it's seamless, then let's say in this hybrid reality, and not constantly experience disruptions of the self and world as we move between, right? So we know if we look at work in the neuroscience space, right, and psychology, that experiences of ourselves, of our surroundings, and of others get formed through a complex interplay between our multiple sensory signals, right, input data coming in, our internal mappings, our mental model of the world, and our notion, our idea of the self. And so this sort of includes not just a bottom-up sensory input processing, but also sort of a top-down system dictated again by our attention and focus and other cognitive models of our body and the world. And an important feature and an interesting feature of these internal mappings is that they're changeable, and they can be altered with repeated exposure to newer or even unnatural newer experiences. And one example that you might be familiar with is the Innsbruck goggles experiment.
Are you prepared to wear these right-left reversing spectacles for several weeks without interruption?
I wanted to just stop the video there. But mostly in the goggles experiment was, done in around 1931, that you wear these goggles that flip your left, right, and up, down. And you wear them for a couple of months and then see if your perception and your brain is plastic enough to actually make that your new reality. And turns out it is, right? Initially, you make a lot of mistakes, and eventually your reality gets altered to this new type of atypical experience, which becomes the new normal for you. And so it's interesting that, atypical experiences can be found in several mental conditions. For example, people with schizophrenia spectrum disorders. Those schizophrenia patients will say, for instance, things like they feel like their body doesn't quite hang together, or that things around them don't quite feel real, or that they might experience other people as robots. Right, so atypical experiences is not something new that we're finding in VR. Those are already seen in other diagnosed conditions. The fact that we're finding in VR is sort of what the work is about. Right, so in this work, we suggest that similar disorganizations of experience, as we just saw in people with schizophrenia, can also be found among some VR users, and that's what we're calling experiential artifacts. This sense of your own body and of the world that gets changed after you've been in VR for an extended period of time. And so what we noticed is that when transitioning from the virtual world to the real world, several users report experiential structures that linger on. Sort of we can think of as after images, right, or hallucinations from the virtual world that you bring with you into the real world, and that can cause some disruptions in your daily life. Right, so these dissociations are what we call experiential artifacts, and we mostly did an informal survey. We did online with 76 VR users to sort of figure out what different types of artifacts might exist, what might their durations be, and then we think that situated VR, and I'm going to talk a little bit about how I define situated VR, can actually help mitigate these experiences, right? So dissociative is just, you objects don't feel solid, other people don't feel real, or your hands feel like they're transparent. And when you have situated experiences, then we can mitigate some of these feelings. And so our survey we did on Reddit and multiple different subreddits, the virtual reality one, the Oculus Quest, the VR chat. And again, people responded, we asked a few questions, maybe 3 or so questions, and people responded with varying degrees of detail, right? So 76 people responded. It was just posted for 1 day. And 40 of those people submitted extended descriptions of the ease they had experienced. And so the responses included EAs experienced after being in specific VR applications, for example, Half-Life Alyx, sort of my background, and Super Hot being another example game. And, our work doesn't cover all sorts of EAs, all sorts of VR experiences. It's not supposed to be exhaustive, or even doesn't even try to understand the specifics of which aspect of a VR experience may have caused a particular experiential artifact. And these are things that we plan on exploring in future work. Here, we're sort of proposing the idea that these things exist, and there's something that, we need to sort of keep in mind and design for to mitigate. All right, so the first one, 58% of the 40 participants who gave us detailed information was this idea of, body, their sense of body, an altered feeling of body, of objects, of reality, and other people that lingers in a post-VR session in real life, right? So again, this is a self-selected group of individuals, and it might be broader, or we also don't know whether they were new VR users or they had been using it for a while. But we do know that these occurred in participants when they were in VR for about at least an hour in length, right? And they lasted anywhere from 1 day, or 1 hour, I should say, to 5 days. And one of the most reported anomaly involved atypical feelings of their own bodies, especially hands, right? And that's not super surprising, because in most consumer VR, hands are pretty much the only things right now that are engaged. You generally don't have a full body avatar. You don't really have much other sensory modalities either. And so these experiences included reports about, body parts not feeling that as if they were their own, or people feeling like they can move by walking, use a controller to move in VR. In physical reality, they move by walking. And so people said things like, I felt like my hands were not my hands, or walking felt odd because in VR you use a controller, and most likely teleportation to move around. And while most of these reports concentrated on the hands, we can sort of imagine that once people have full body avatars, maybe the same idea is going to expand and extend to the entire body, right? And that'll be sort of something to explore as it becomes more commonplace. Excuse me. The second one is object rigidity, right? People said that real objects that they would hold would feel floaty and weightless, pretty much how virtual objects feel, because again, haptics are not dominant. You may feel vibrotactile sensations, but if you don't, the lack of sensation of weight and texture and temperature, and a lot of these haptic sensations of interacting with objects are missing in VR. And so when you come out of VR, you feel this notion that, the real world is also not rigid, and that you can walk through objects and that sensation can stay with you. And then the third one is interpersonal feelings, and 23% of the participants said that other people, your interactions with other people were also altered, that they felt like they were NPCs, and that the conversation sort of seemed like they didn't have much content. And so people's experience of other people was also altered, because in VR maybe it's just minimal. Right, so all of these different sensations of disconnectedness in VR, they're more not so much caused by a lack of physical properties. I mean, we think in the virtual space, but more by how the brain and the body map the world and the self in either of these spaces. Right, so as an approach to trying to resolve these, or let's say mitigate or minimize these, we want to sort of design congruent experiences, and experiences of phenomena that sort of maintain some sense of congruence across the real and the virtual boundary. And so in prior work, of course, situated, oh goodness, back. Prior work, situated has been used to refer to a physical location where the user and the object, etc., are situated. And in our case, we're talking about situatedness as the feeling of being grounded in the virtual world, on a world that you can inhabit socially, environmentally, bodily. Okay. Oh, again. Anyway, so the other thing that the text is saying is that in addition to situated, we're also introduced this idea of situatedness, and again refers to this notion of being grounded. Oh wow, it just automatically showed up all the things. Okay, so as examples of, these are the three experiential artifacts I talked about a few minutes ago: experience of body movement, object rigidity, and experience of other people. And in our paper, we talk about corresponding projects, and several of them from our own prior work, of how those can help mitigate these kinds of experiential artifacts, right? Like in the first top row, if we use walking instead of teleportation for movement, then maybe this notion that we can teleport in the real world is going to go away, because you never really did it. You were walking in VR. And we all know how hard a problem that is to solve, right? In terms of object rigidity, passive haptics and a combination of active haptics can help. But again, it's really difficult to recreate all the sensations human skin is capable of feeling, because almost all haptics end up needing a device which is sort of single purpose. Like this haptic device can simulate weight, this one can do temperature, this one can do something else. There is no single system that can do all the sensations of the skin. And in the third case, our experiences of other people, again, can be enhanced. We have other people that are not floating around without bodies, but maybe once we are more embodied in VR. Right, so while experiencing or achieving experiential congruence through situatedness, maybe it can help reduce experiential artifacts, and we can create VR experiences that have a high sense of presence. We could also argue that if an experience that we create is the same as the real thing, it could present its own downsides, right? By maybe leading to confusion about what is real and virtual, sort of what we see in the Matrix, where there is very little, it's hard to tell which is which, right? But on the other hand, if we look at the limitations of current technologies, we can argue that regardless of realism of experience, if, let's say, VR and AR become deeply integrated into our daily lives, right? Much like our current online lives, we have access to them all the time from our devices that we carry in our pockets. Then this new hybrid reality will become too meaningful for us to not be regarded as real. So it becomes real in a different sense, right? And so both those scenarios are possible. The second one more likely given our technology. And so the current, at the moment, each VR system and experience is sort of fragmented. It's an own ecosystem, and there's lots of variability in different forms of locomotion use, different forms of interactivity, some haptic feedback, rigidity of objects, shapes, etc. Lots of variety across VR experiences. And so you have to exit one to enter another. Your own representation of self changes continually across these, however minimal that representation is. And so it's not really yet a permanent, always on type of reality, right? That is tied to, let's say, contextual elements of the real world that allow you to bring in or make that transition between the real and the virtual a lot more smooth. And maybe that's sort of where this whole notion of, building out our immersive experiences going towards. Right, and so for future work, there are several things that we can start exploring. One is whether, immediate questions being, do these experiential artifacts change over time? And what exactly is their impact on our sense of bodily, object, and social experience in the real world? Then can we actually categorize these EAs and estimate their prevalence, right, through maybe a more formalized study? Can we also investigate whether they occur in other modalities? Like, does AR lead to it or MR? I mean, if we think about it, many real world things could lead to an experiential artifact, right? And the other day I was talking to a student who said that when they play chess for many, many hours and then come out of playing chess, then the whole world looked like a checkerboard. And so it's not necessarily just related to VR. But so right, it's a worthwhile thing to explore. And then how can we evaluate ways that design experiences that can actually mitigate them? Or can we say specifically, if you do this, then this will get mitigated? Right now, we're sort of saying most likely it will, because of the congruence it creates, right? Like walking in real life and walking in VR is congruent. All right, so circling back around, right, I talked about a project related to learning. I talked about time travel, and talked about experiential artifacts, and coming back to this idea of what work my lab is doing and interested in doing is augmenting our physical abilities. And the idea is that in the real world, we can capture your context, your body pose, your facial expressions, your attentional information, your emotional information, your activity. There are many different types of data when you're doing a physical task that can be collected. And then there's many different ways we can use that data to present information to you, whether it's instruction or guidance or feedback, any of it, right? And of course, all of this will end up being provided through some form of wearable device, because that leaves your hands free to do the physical thing you're trying to do, whether it's cooking or repairing or trying to do exercises for rehab, etc. Right? So AI can help us both at both ends, in both estimating in real time what's going on, like modeling the user in real time, and then creating output also in real time. And to get to that point, of course, there's many challenges that need to be overcome, challenges related to the design of AI models themselves, the user interfaces, and then the engineering of entire systems that are taking all these disparate data together to build something that works as a full system, right? So for AI, something is the fundamental thing you need is a data set, but for all these physical tasks, there's hardly any data sets, right? Is there a data set on physical rehab for knee therapy? Or is there a data set for estimating the user's emotions while they're performing, let's say, repairing a car? Those are going to be very different maybe from when you're watching a video online, right? So the first step for us in our work is building these data sets. And at times, building such a data set requires building new hardware, new types of devices that can actually capture this, whether it's some sort of exoskeleton, a wearable device, or something else that can capture body data. And then the next step, of course, is building and designing interfaces. And whether they're AR, VR, or mixed reality, what have you, how do you build? The bigger challenge, I think, is building interfaces that first off allow you to trust this AI instructor agent that's going to try to help you to do a physical task, right? And how do you build that trust through the interface? Because AI is going to make mistakes, and AI's output may at times not even match what you're actually doing. And so in that case, who is in charge? We don't want to take agency away from the user. We also want them to not totally blindly trust the AI model. What is some in between that works well? And then, of course, as I said, these systems need to run real time on edge devices. And how do we actually engineer all of this for it to be actually meaningful to people in the real world, right? And so just to wrap up, I want to summarize that I talked about how I think of AI as a material, so as Play-Doh that we can use in different forms and shapes with existing things. And what is the other thing is I'm interested in using this material for augmenting physical abilities, our ability to learn new skills, our ability to recover skills that we may have temporarily lost, our ability to do things that we were never able to do or could do at one point but can no longer do. And lastly, build upon our own skill sets to speed up our ability to learn, sort of short of a future where we might be able to download physical skills directly into our brains. And all of this, in my opinion, has tremendous potential for societal impact worldwide, as we saw the statistics earlier. And in general, I hope that many of you will join me in trying to make this potential a reality. And I think with that, I am right on the hour. I'm going to stop, and I'd be happy to answer any questions.
Amazing. Thank you so much for this talk. I've never thought about AI as material before, but it does make sense. And you brought a lot of interesting questions, interesting ideas. So now I guess we are taking questions. I have one question to start, but please feel free to ask your question after. I was wondering in the learning part where you had famous characters, they are trying to teach people, I guess, or taking the role of a teacher. I was wondering if there was a different role for the AI as a, for example, we have some research where the AI will play an opponent, so sort of like something you're competing against. Would that, you think, impact the likability and other emotions, you think, from your perspective, or any thoughts about that?
I would say, and I'm just trying to base this on how we work in real life when we are competing with folks. It can be both, right? Like if we compete with somebody and you see real sportsmanship on either side, it leads to positive feelings overall, versus the same kind of competition with a different personality of an individual can also go south depending on how the interaction goes, right? And so it will probably depend on the context, the scenario that this kind of instructor is being used, or I guess a competitive entity, but not an instructor is being used, and how that competition goes. And so I would say there's potential for going both ways.
Yeah, of course, it depends on the context. Any question from someone else?
Oh, I had a question, and I should apologize. I need to run to another meeting shortly. So, but really amazing work. I wanted to ask about your living pictures. So, if I understand it rightly, and maybe you can correct, to make sure the picture actually gives information as the character, you had to change the pronouns and the text, and then you would feed that text back into the character to train it. Is that how it worked?
Right. So we changed the pronouns in the output that's coming out because we didn't want the GPT-3 going out and searching for something about Leonardo da Vinci. We wanted to restrict it to responding with responses that include pronouns like I, me, my. Ultimately wanted to constrain the output so that it stays true to the original source that the whole system is trained on, versus trying to find random information from all over the web and putting it in as also a potential response, which could seemingly appear realistic, but we didn't want it to happen because it's factually not close enough to the original source data.
Great. And then given so if you wanted to do that for somebody who is living, so for example, if I wanted to have my photo of myself talking, and I want to talk about augmented reality, which is my expertise, could I feed or train that on a bunch of my papers or some other statements I've made, and then use that in parallel with GPT-3?
Yes. So I think what we were trying to do is have Leonardo answer with the kind of knowledge, attitude, style of talking, and all those parameters that are reflected in the original content. If we build and train something on your papers, I think that's going to come across. That's not how you normally talk. It does represent your work,
of course, yeah.
right? So the style of instruction or conversation might be quite different from what it might be if I were to talk to you as another researcher or colleague. And so, but it's doable ultimately, and it's tweakable also because we can manage to change and give it more feedback and come up with different types of outputs.
I guess you have to train it on, for example, videos or conversational material. Yeah. Okay, that's great. Thanks so much. And
I'm sorry, what we want to capture.
Yeah. And I'm have to run to another meeting, but that was really fascinating, and I'll look forward to seeing the video of the rest of the questions people made. So thanks so much. That was really great.
Yeah, thanks, Mark.
See you.
Thank you, Mark. Question from Gun.
Hello.
Yeah, thank you very much for the great talk. It was very inspiring. Just related to that talking head picture of Leonardo, you've mentioned what you're trying to do is not to copy an existing person. I understand that from the ethical perspective, but is there any other aspects that you were considering other than the ethical aspects regarding trying to avoid from copying those people who are currently alive?
Right. I think the two things that we're really, well, three things I should say we're really mindful of is one, trying to ensure that the responses of the chatbot are close to the original source that it's trained on, that there is no external random information added. The other thing is that responses to questions about things that Leonardo could not possibly know at the time when he was alive, the model technically should output, I don't know, or I'm not sure, instead of actually coming up with, like the United Nations example that GPT-3 gave. It just said some answer, which is not possible for Leonardo to know. And the third thing is, oh, I forgot the third thing. But mostly we're trying to make sure that the entity stays true to itself, right? And again, it's a representation of Leonardo at a particular point in life, and that point in life being the time when he wrote that journal for whatever period that it was written for. It's not a representation of Leonardo when it was younger, when it was older, or it's a particular time frame in his life. And I think that's sort of the third constraint on the design.
Great, thank you.
Thank you, Gun. Question from Mitchell.
Hey, good talk. I was wondering what so did anyone try and force Leonardo to say things? So you were saying that you tried to restrict it so that it wouldn't talk about things that he wouldn't know.
You mean like how people are doing Dan with ChatGPT?
Yeah, like hacking the AI basically, and sort of tricking it into getting responses that it shouldn't give. Was there any attempt to do that, and what responses came from that?
Well, it was a fairly constrained study, right? People had a task to do. So as far as I know, we didn't really have people doing, basically trying to hack the system, right? Which I imagine at some point is potentially hackable. If ChatGPT is hackable, then I'm sure our system is hackable by giving the whole Leonardo different personality and going through the whole game process. But we didn't really see it in our study. And the system isn't out for use as a public system yet. And I expect if it went out, then we'll see more. Though I'm hoping also that because we constrain several things, and we also make sure that there's a check of, the output similarity to some piece of text from the original source data, that will actually prevent that kind of thing from happening. But
So
we could be surprised too.
no one sort of internally, none of you guys like researchers have actually tried doing it yourselves just to see what happens?
Not in the short time that we were doing the study, no.
Okay. It'd be interesting to see if you could.
Yeah. Actually, it'll be interesting, but also be helpful for us to understand that whether our cosine similarity score is too low or too high, to see if we can tweak that to prevent something like this, or it'll sort of help figure out what other ways could we come up with minimizing that kind of thing from happening.
Thank you, Mitchell. Question from Yun Wu.
In research, and my question is related to your learning studies. I think a learning process like e-learning.
I'm sorry, it sounds, yeah.
So yeah, I will type on the.
Okay, we'll get your question on the text and chat. Meanwhile, any other questions? I guess I will ask a question I wanted to ask at the end, but now seems to be a good time. I wanted to ask about the transferability of skills. Which part, like the one you said where we can download our skills in the future, like in the matrix, which part of, I guess, the journey or the research you have done so far where you think it can apply or reach to that direction?
So transference is something, let's say you're repairing something, right? And you know how to repair a car, and you know enough about how things function. Can we build on that to help you repair, let's say, I don't know, a helicopter engine faster, that you don't have to learn everything from scratch? You already have some baseline, and that's where you're going up from. So for that system, right now, we're in the process of user modeling, because the type of feedback, when to give the feedback, how to give the feedback, and what modality and duration and all of those things make a difference, right? We sort of don't want to be clippy, an AI clippy, so to speak. We want to be able to know enough about the user's emotional and attentional states so that we can make an informed decision about, oh, the user is they're focused, even if they're having a hard time with the task, it appears that they want to solve the task themselves. Let's not disturb them and offer them help. Versus the user seems really frustrated, this would be a good point to give them assistance or tell them how to do the task or how to progress to the next stage, right? So all of those things require us to model the user in real time, their emotional state, their attentional state, maybe their body pose and things like that. And so right now we're in the process of building a wearable device that you can put on your head and we can track a user. It's wearable because the user is going to move around a physical space to do the task, right? We can't put 10 cameras in the space, and if the user is looking down, you still can't capture their face. We can put a camera on the floor or whatever, but it's just more work instrumenting the space than having a system that's mobile, goes wherever the user goes. Not only can it capture data, but in real time, when we want to use the system, the same data can help us do inference and give user feedback in real time based on what we estimate their state to be. So for that, and the same hardware that we're building can apply also to learning skills, because people are trying to learn something new. Can we give them real-time guidance, give them a process to follow step by step, do this, or this is how it works. And then do it in an intelligent manner, right? So you can imagine if you have a friend who knows you really well, and a friend is watching you do things, they're not going to sort of just do it for you, right? They want you to learn. They're not going to interrupt you every few seconds to say, no, do this, you're doing it wrong, kind of thing. They sort of know you enough to give you help when they really think you need help, and they're estimating it based on what they know about you, what they see you doing, and they're modulating their own ability to help and the type of help they offer in real time as they observe you doing things. And sort of that's our hope, to be able to design an AI system that can sort of perform. Maybe it's not going to be as good as that, but to some extent, be something like that.
I see. Yeah, I guess I didn't see the link. Well, I understand the idea about assistive AI, but I was thinking if it will reach to a point where like it's downloadable information you already directly
That's
in your
sort
brain.
of way down in the future.
Okay.
Like, that needs
Yeah.
a lot of work in a lot of different domains, us even understanding
Yes.
your brain fully, and we don't have that. So it's sort of far future.
Absolutely. I'll go back to question for when Wu is he's saying question about the motivation. That could be that motivation. Can the motivation improvement affect given the virtual tutor be maintained continuously?
I think so. That's something that I said is potential future work, where you have to do sort of a longer term study to even figure out if it's possible to maintain that and what kind of impact will it have, right? Repeat exposure might make things worse. Maybe you like someone today, and then after seeing them every day, you don't like them so much anymore. It's kind of hard to say without actually doing something longer term to figure it out. Does that answer your question, Kimbo?
Yeah,
great.
It seems that in Australia they have been having Wi-Fi issues as well. So sorry about that. We have, yeah, I think I thought there was a question from Tamil, but he was saying just thank you for the great work.
I think I have to leave for a meeting.
One last question, if you may. You brought a point about building the data set is a challenge for this AI. What would you recommend when we're trying to build or use AI as a material, and we want to build this data set, but we don't have, I guess, the time, or there's a lot of limitation to do that? What would you recommend? What's the best way to go forward?
I guess it depends on what is your end goal, right? Like, let's say your end goal is to look at different types of feedback modalities you consider, right? Given, let's say, the task I was talking about earlier. And so the feedback could be audio, feedback could be visual, could be 3D and AR, depending on the task. If your goal is that, you don't really have to go through the whole process of building a data set and building a model and building a system. If your goal is only to understand the interface, you can simulate that, and you can Wizard of Oz a lot of things. For some things, you may not even need to build a data set, because let's say egocentric data sets exist already. And if your task falls into that domain, like cooking, for example, then you can already find a data set. So it kind of comes down to what is it that you care about building, right? Really thinking about that and thinking about whether it's possible to just use an off-the-shelf model that will do the job for you, because your goal is more about the interface design, or you care more about building a new model and you want to have a technical contribution there, and then you want to see, you need a data set because you're looking at very specific aspects of the challenge of a problem that are not covered in, let's say, Meta's Ego 4D data set or something like that, right? So it's more a matter of asking yourself the question of what is it that's most fundamental to your research that you want to elicit, and how best get that out, versus sort of building a system, because engineering takes a long time. It's taken us a year or so to build the entire hardware to be able to collect the data set, and the question is, obviously now we'll use it to collect data and then build models. That's what we wanted to do, but depends on, what do you want to do and where do you want to publish? Systems papers may not be appreciated everywhere. It just kind of depends.
Yeah, understand. It's about focusing where is the contribution going to be as well. Well, I think that brings us to the conclusion of this talk. So thank you so much, Misha, for taking the time to talk to us. Sharing your ideas is very inspiring, and we learned a lot from this, and hope we can meet and collaborate in the future if possible.
That would be wonderful. Thank you very much again for hosting me.
Thank you
Thanks,
everyone for
Misha.
joining.
Thanks,
Bye.
Misha. Thank you.